Happy Friday! We're going to do some examples together on page 7 in your packet. So the directions say, for the following function, state the conditions of the mean value theorem. If the mean value theorem is true over that interval, find the value of c. So the first thing we want to check in our mean value theorem is the function continuous? And yes, f of x is continuous because it's a polynomial and there are no breaks. It's a smooth curve. Secondly, is f of x differentiable over the interval? And again, because it is a polynomial, yes, f of x is differentiable. And these are both over the interval, -7 to 1. So it fills both criteria of the mean value theorem. So now we can apply it. And over here on the side, I'm going to do some scratch work. First, I'm going to find f of -7. I'm going to plug in the endpoints of the interval into the graph. And I'm also going to use graph trace. So if you can take a minute and type the equation into your graph page, and then press trace, that'll help you find the values at the endpoints. Okay, so easier than plugging them in. So first, I'm typing that in, and I'm going to find f of -7, so press trace and go to -7, and it turns out that that value is -27. And then also let's find the other endpoint, f of 1. When I plug that in, I get -35. And also, I'm going to find f prime of x. This is like my scratch work on the side that I'm going to need to apply the mean value theorem. So f prime of x, the derivative would be 3x squared plus 16x plus 4. Okay, now I'm going to use the mean value theorem, which says, and let me just write it up here over to the side. So the mean value theorem says that f prime of c is equal to f of b minus f of a all over b minus a. So this is the equation that I want to use. So f prime of c is the same as f prime of x. So I want to set my derivative, 3x squared plus 16x plus 4 equal to the equation of the secant line. So f of b, so this is like my a and this is my b. So f of 1 is -35 minus f of a is -27 all over 1 minus -7. All right, now we have to do a little bit of math. So -35 minus -27, and then divide that by 8. That turns out to be -1. So now I have 3x squared plus 16x plus 4 equals -1. I'm going to come up here now and finish solving this. So 3x squared plus 16x, add the 1 to the other side, so plus 5 equals 0. Factor this. So I know I'm going to start with 3x and x. The only things that multiply to 5 and 1. So that's going to be 1, 5. They're both positive. So my two solutions are x is -1/3 and x is -5. So what are those two values? Those are the two values of c where the function is going to have the same, the tangent line will be the same as the slope of the secant line. So that's complete. All right, so now let's take a look at letter B. First, we have to check the criteria of the mean value theorem, and this one has an asymptote. You notice there's an x minus 3 in the denominator, so that means that f of x is not continuous because there is an infinite discontinuity or asymptote. It's also not differentiable for the same reason, because of the discontinuity. So now let's look at some Rolle's theorem examples. First of all, we've got f of x over the interval -5 to 3. What are the criteria of Rolle's theorem? So the first criteria is, again, is it continuous? Is it differentiable? And again, it's a polynomial, so there are no breaks or jumps. It is continuous and differentiable. So f of x is continuous, f of x is differentiable. Now, these should technically say both over the interval -5 to 3. The third criteria of Rolle's theorem is, does f of -5 equal f of 3? Let's check our work over to the side. So f of -5, f of 3, and again, I'm going to type the function into the calculator and use graph trace to find those values. So I found that f of -5 is 20, f of 3 is also 20, therefore Rolle's theorem can apply because those two x values have the same y value. So now let's go ahead and apply Rolle's theorem. So Rolle's theorem says that I can now set the derivative, and I should add that over here to my scratch work. What's my derivative? 3x squared plus 8x minus 11. So set the derivative equal to the slope of the secant line. Well, if I did the slope formula, 20 minus 20 would end up being 0. So really, I want to know where is the derivative equal to 0. And I can go ahead and factor that into, let's see, 3x and x multiplies to 11, so it's going to be 11 and 1. This is going to be positive, negative. So if I solve this, I get the two x values. X is -11/3, and x is 1. I would want to make sure that both of these x values lie within this interval, and they do. So those are both the two values of C where Rolle's theorem applies. All right, let's take a look at example B. This graph, if you remember, is an absolute value graph. It is shifted down 1. So if we had to sketch a little picture, it looks something like this. Now, an absolute value graph is continuous, so f of x is continuous over the interval. However, because there's a corner here, f of x is not differentiable. So it's not differentiable because there's a corner. Therefore, Rolle's theorem cannot apply. And finally, f of x equals the square root of 25 minus x squared. If you type this into the calculator, you'll see that it is a semicircle with a radius of 5. So the graph looks something like this. And over the interval -4 to 3. Well, first we would check to make sure, is it continuous? Yes, there are no breaks in the graph, there's no jumps in the graph, so it's smooth from -4 to 3. Is it differentiable? I don't see any corners or cusps, so yes, f of x is differentiable. But now I have to check the third criteria, so let's go ahead and plug in our two endpoint values, f of -4 and f of 3. If I plug in -4 into my function, I end up with -3, and if I plug in 3, 25 minus 9, 16, square root of 16 is 4. Those are not equal, so f of -4 does not equal f of 3, therefore Rolle's theorem does not apply. Now with your neighbors, please try the examples on page 8.